This is a recording for lesson 4.5, part of Math 020 Pre-Algebra course taught at St. Louis Community College, recorded by Dr. Victoria Shearing. Lesson 4.5, we will learn how to add and subtract fractions with different denominator. We have two objectives for our lesson. Finding the least common denominator is going to be objective number 1, and number 2, we will learn how to add or subtract fractions with different denominators. In the entire course, this is probably the most challenging lesson, so some of you might have to review this video a couple of times or go over the problems a couple of times over. Our first objective is to get an understanding of the least common denominator. When your fractions have different denominators, we cannot straightforward add or subtract them. We need to create the common denominator between those two, and that denominator should be the smallest denominator possible between those 2 or 3 fractions, however many you're adding or subtracting. The definition of the least common denominator of two fractions is the least common multiple of their denominators. We talked about the multiples of numbers in lesson 2.4. So if you need a quick review on the concept, you should watch lesson 2.4 video or go back to your workbook in lesson 2.4 and double check that you remember those concepts. We also talked about the equivalent fractions property, meaning that the two fractions are equal to each other if their numerators and denominators are multiplied by the same number. We talked about that in, let's see, lesson 3.2 or 3.3, one of those, 4.2 or 4.3, one of those sections. Again, if you need to review that, please go back to the previously recorded videos and review the equivalent fractions. Okay, so we're adding the new element today is how to find the least common denominator. In order to find the least common denominator, you will need to factor each denominators into prime numbers. Then you are going to list the prime numbers, matching factors in columns if possible. You're going to bring down the columns and multiply the factors. The resulting product is going to be your least common denominator. All right. So here's our example how to do the least common denominator. So here we have the two fractions, 7/12 and 5/18. So we're looking for the new denominator that would be least common denominator for 12 and 18, meaning that it's going to be a number that is greater than 18, and 12 is going to be a part of it, or 18 is going to be a part of it. Okay, so we start with factoring each denominators into primes. So 12 is factored into 3 times 4, which can be additionally factored into 2 times 2. So for 12, we would list 2 times 2 times 3. 18 is factored into 3 times 6, and 6 is further factored into 2 times 3. So for 18, we would have 2 times 3 times 3. So once you have your factors, 3 times 2 times 2 for 12 and 3 times 2 times 3 for 18, your step number 2 is to list the primes, matching factors in columns if possible. So this is what they meant by saying matching in columns if possible. I know it's pretty fuzzy because I copied it out of the free textbook. All right, so you have the 12, 2 times 2 times 3, and the 18 is 2 times 3 times 3. Notice that I match the 2 and I match the 3. So now the next one is bring down the columns. So I'm bringing the column with the 2. I'm bringing the next column with the 2. I'm bringing the column with a 3 and the last column with a 3. Notice that if I have the same number in the same column, I do not need to rewrite that twice, I just get one of them. So I have a column of 2's, which is here, it is number 2. I have the second column of 2's, which I only have 1 2 in there, but I'm bringing that down. I have the third column of 3's, so here is my third 3, and the fourth 3. Okay, so once I multiply all these numbers, the least common multiple is 36. Okay, now let's double check. 12 goes into 36 3 times. So 12 times 3 is 36, and 18 times 2 is 36. So both numbers go into the 36, and you found your least common denominator. Okay, so we're going to look at our, so please keep that example in mind when we're looking for our least common denominator for each set of the fractions. Before you start listing the factors, you have when you have two fractions and two different denominators, really quickly check if your smaller number goes into the bigger number. So in part A, 5 is a multiple of 15. So you can totally use 15 for your least common denominator because that would be the smallest number where each 5 and 15 go. 5 times 3 is 15, so 5 is part of the 15, and 15 times 1 is a 15, because you can always multiply the number by itself. Okay, so the LCD for the first set of fractions equals 15, because 5 times 3 equals 15, and 15 times 1 equals 15. So this is the easy case where we don't have to list the factors of both numbers. Sometimes you can ballpark it. Sometimes you can also use your multiplication table. So you don't always have to do that extensive work that we just did in the first example. You only do that when you're absolutely at a loss and you don't know, you can't think of a number that your denominators would go into. So next one, 14 and 21. There are multiples of 7. So if you quickly check your multiplication table for 7, you might be able to find it, but not really sure. So so we know that these are multiples of 7. 14 and 21 are multiples of 7. So check multiplication table. So we would have, in multiplication table with 7, we have 14, 21, 35, 42. 21 would go into 42, and 14 would go into 42. So the LCD, so 14 times 3 equals 42, and 21 times 2 equals 42. So the LCD here is 42. Okay? So this is the second way of how to find the LCD. For the next problem, we are going to be using the method that the multi-step method, where we will break our 18 and 24 into the prime numbers. But I wanted you to see that there's two other methods that you can do. So you can either, so when you have the small number and the big number, check if the smaller number goes into the big number, like in part A. Check the multiples on your multiplication table if you have multiplication table handy. And then now we're going to use our rule that we had at the beginning. All right, so 18. 18, if you are going to represent that as the product of primes. So 18 is 2 times 9, and 9 is 3 times 3. So 2 times 3 times 3 is your 18. 24 is 2 times 12, and 12 is 3 times 4. Okay. And then 4 is also 2 times 2, which I am going to, so 2 times 2 times 12, 24 is 2 times 12. 12 is 3 times 4, and 4 is 2 times 2. So I have my prime factorizations for 18 and 24. I line them up in my columns. So I will have a 2 factor, 3 factor, and then I will have all the other ones. Okay. So I don't repeat the factor, but if it's occupying the column, so it's 2 times 3 times 3 times 2 times 2. So let's go ahead and multiply that through. So we have 8 times 9 will get you 72. So LCD equals 72. Okay, did something wrong. LCD equals 72. Okay. Now you could also double check your multiplication table, but you would have to be really good about multiplying and understanding where if your 18 goes into 72 or 24 goes into 72. Once you start working with the bigger numbers, it's always easier to break it down in factors and then list the factors and then multiply all the factors together. Okay, so let's go ahead and look at the next three problems. The next two problems. We have 9, 12, and 18. Even though 9 goes into 18, 12 doesn't. So I can't use 18 for these. This would be too easy. So I am going to start with the factorization, prime factorization. So for 18, I'm going to start with the bigger number. 18 is 2 times 9, and 9 is 3 times 3. So 2 times 3 times 3 is your factorization. Again, if you need your review of how to factor a number into primes, please go back to 2.4 video or your notes on 2.4 and review how to do that. So then we're going to do 12. 12 is 2 times 6, and 6 is 3 times 2. All right, and then I have 9 is 3 times 3. Notice how I match my factors. All right, so now I'm going to bring all the factors. The first column gives me 2. The second column gives me 3. The third column gives me 3, and the last column gives me 2. So I have 4 times 9, which is 36. So my LCD is 36. Okay, so for this one, LCD equals 36. You multiply 2 times 3 times 3 times 2. All right. 7, 14, and 21. Okay, so start with 21. Factors into 3 times 7, both prime numbers. 14 is 2 times 7, so I'm going to do 7 and then 2 because I can't put it under the 3. And then the 7 is a prime number, so it's just 7. Okay, so let's go ahead and find the LCD. So I'm going to bring 3 times 7 times 2. LCD equals 42 once you multiply them through. Okay, so this is our first skill, how to find the LCD. Once we find the common denominator, we're going to change our fractions to reflect the common denominator. So we will use our skill that we learned about the equivalent fractions. So we'll have to figure out the multiplier to get to the new fraction. All right, so but before that, now we're ready for our formal rule, how to add or subtract fractions with different denominators. So the step one, find the LCD. This is what we just did. That's the reason why we did spend so much time on step one. Find the LCD. Step number two, convert each fraction to an equivalent form with the LCD as the denominator. Step number three, so after step two, you will have the same denominator. So you will have two or three fractions with the common denominator. And then step 3 and 4, we already know what to do. Add or subtract the fractions, numerators. Keep the denominator the same. And then step number 4, write the result in simplified form, meaning reduced to lowest terms. So step 3 and 4 we've already practiced. We just did step number 1. So the only new step is going to be step number 2, practicing how to convert each fraction to an equivalent form with the LCD as the denominator. So let's go ahead and look at our first example. So we have step number 1. In example 2, part A, where we're adding 2 over 9 plus 1 over 18. In first step, we need to find the LCD. Okay, 9 does go into 18, and 18 will go, like the number will always go into itself, but 9 times 2 is 18, so 9 goes into 18. So my LCD that I'm going to use is LCD equals 18. So that's your step 1. Step number 2, all right, again, convert each fraction to an equivalent form. So we had 2 over 9. Now it needs to be over 18, okay? That's the new denominator, okay? So let's see, 2 over 9. I don't know what the numerator over 18 is going to be, but I do know that 9 goes into 18 exactly 2 times. So to go from 9 to 18, I multiply by 2. 9 times 2 equals 18. So that means I need to multiply 2 by 2 as well. So 2 times 2, the new numerator is 4. 2 over 9 is equivalent fraction of 4 over 18 because it's just numerator and denominator multiplied by 2. We're going to do the same to the 1 over 18. Okay, so this is your step number 1. This is your step number 2. So we're going to take 1 over 18. Oh, we don't need to do anything there. Okay, so because the 1 over 18 already has the LCD, so we only needed to change the first fraction. So number 3, step number 3, we are going to add them. So now I'm adding 4 over 18 plus 1 over 18. I know how to do that. We've already mastered that in 4.4, in lesson 4.4, so that would be 5 over 18. And just double check for your step number 4 if we need to reduce it to lowest terms. 5 is a prime number, and the only way we would reduce the 5 over 18 if instead of 18 we had either 15, 10, 15, 20, or multiples of 5. So there's nothing to be done here. The correct answer is 5 over 18. Okay. Moving on to the next one. All right, you have in part B, you have 5 over 6 plus 3 over 8. Okay, so let's go ahead and do step 1, find the LCD. All right, so 6 is 2 times 3, and 8 is 2 times 2 times 2. So the LCD is 2 times 3 times 2 times 2, which is 24. So your LCD is 24. Step number 2, I need a little bit more space here. Just going to have to write below the line. So step number 2, I'm going to start with the 5/6. So this is the old denominator. Now the new denominator is 24. So I need to change the numerator as well. So 6 goes into 24 4 times. So 6 times 4 will give me 24 on the bottom. So I'm going to multiply 5 times 4 as well to reflect that change. So the first fraction now is 20/24. Okay. I'm going to do the same to 3/8. 3/8. Now the new denominator is 24. So 8 times 3 would give me 24. So I need to multiply 3 times 3. Remember, this has to be the same number, but it's not the same as the first fraction number. So the first fraction had to be multiplied by a 4. The second fraction had to be multiplied by a 3. That's why it's so challenging. So 3 times 3 is 9. So now my two fractions that I am working with, my two new fractions are 20/24 and 9/24. They have the same denominator, which is what I wanted. So now I can do the step number 3. I am adding 20/24 plus 9/24. So keep the denominator, add the numbers, 29. Okay. And there's nothing I can do here. We are not going to be converting that to a mixed number unless I am specifically asked in the problem to convert to a mixed number. So we have our answer, which is 29/24, and we are done with this problem. All right, we have 2 more problems, which will give us a little bit more practice with common denominator and adding or subtracting. So the first thing here on part C, I have -19/20, and I'm subtracting -5/8. Because I have the double negative without the number in between, okay, I can rewrite my problem first as -19/20 plus 5/8. Okay, -19/20 plus 5/8. Okay, so I am going to take care of the negative sign when I actually do the numerators. But for now, let's find the LCD. So the LCD